In this video, I'll show you how to find the volume of solids using integrals. This is part 2 in the series. Question 1 reads, find the volume of the solid obtained by rotating the region bounded by y is equal to x to the power of 4 and y is equal to x to the power of a quarter about the x-axis. Y is equal to x to the power of 4 looks like this, whereas y is equal to x to the power of a quarter looks like this. What they're asking for is what happens if these two functions were to rotate about the x-axis. And just to give you a visual of what it would look like, take a look at the right corner of the screen. Notice that you'll end up with an ellipse-like three-dimensional shape with an elongated cone taken out of its middle. It's hard to describe. To do this question, we'll need to find out where these two functions intersect. So anything outside of their intersection points will not be accounted for with the volume. To find out where they intersect, you have to make them equal to each other, where you have x to the power of 4 is equal to x to a quarter. And the only time when x will be the same on both sides is when x is equal to 0 and when x is equal to 1. Those are the points of intersection. They will intersect here and they will intersect here, and that's it. So these will be our lower and upper bounds for our integral. And we have to set up the integral so that it looks like this, where we have volume is equal to 0 to 1 a at x dx. A at x is a function that we have to create right now. And if we were to take a slice out of this 3D shape that's being formed, take a look at the top right of the screen in case you forget what it looks like, you will end up with a circle within a circle. We want to find out the area of this part because this part is hollow. What we have to do is subtract the outer radius from the inner radius. The outer radius will be this function and the inner radius will be this function. So the formula for the circle representing this function will be pi r squared, and we'll call this r1, where this represents r1, minus the area of this part of the circle, which we'll call r2. I'm going to replace the r's with the function itself, pi x to the power of a quarter to the power of 2 minus pi x to the power of 4 to the power of 2. Once again, I've replaced r with the function itself because the radius of this circle represents the function. Let's go ahead and clean this up a little bit and see if we can reduce any of these terms. X to the power of a quarter to the power of 2 is x to the power of half, pi, minus pi times x to the power of 8. Factoring out this pi, we have x to the power of half minus x to the power of 8, and this will serve as a of x. Let's go ahead and substitute that into the function that we're building. Pi x to the power of half minus x to the power of 8 dx. From here it's not hard. First we can take this out of the integral, this pi, and worry about it later. We need to find the integral of x to the power of half and the integral of x to the power of 8. The integral of x to the power of half is 2 times x to the power of 3 over 2 over 3. So we just found the integral of this. Now we can find the integral of that, which is easy to do. Add 1 to 8 gives us 9. We end up with 1 over 9 x to the power of 9. Let's rewrite our function with what we just found. And we will evaluate this from 1 to 0. So substituting 1 into both of these terms, we end up with 2 over 3 minus 1 over 9, minus, substituting 0 into both of these terms, we end up with 0, times pi. If you use your calculator to evaluate this, you should end up with 5 pi over 9. And that represents the volume of these two functions. Let's move on to question 2. Now this question is slightly more complicated than the previous one. We're asked to find the volume of the solid obtained by rotating the region bounded by y is equal to x to the power of 3, which looks like this. Of course, this is my x-axis, y and z. And the x-axis from 0 to 2. Let's call this 0, and we'll call this 2. So they want the volume of this rotated around x is equal to -2. So that's over here somewhere. And they want us to rotate this around this point. So we're going to have a huge hollow looking cylinder, something that looks like this. And only this part that's highlighted is the volume. I know it's hard to imagine, but here's how to set this up. What we have to do is, similar to the previous question, is find a function for the area of this line and a function for the area of this part. So we have volume is equal to the lower and upper limits, which we don't know yet. And instead of being about the x, as in the previous question, we'll have it about the y, because it is being rotated like this. Now what this also means for us is that we have to rewrite our function y is equal to x to the power of 3 in terms of a y. And to do that, we'll cube root both sides, where we end up with the cube root of y is equal to x. So this will be our brand new function. And when x is equal to 0, y is equal to 0. And when x is equal to 2, y is equal to 8. So our bounds will be between 0 and 8. To find the area of the circle made by rotating the function around this line, we will use the formula area at y is pi times the radius of this circle, which is 4. And we will subtract that from the radius that this function makes, which is pi times the function, the cube root of y, plus 2. And the reason why I'm saying plus 2 is because this function is not connected to where it's being rotated. There's actually a separation of 2 units. Remember, this is from 0 to 2, and we have from -2 to 0. And so we account for that additional space by putting this plus 2 to the power of 2. I'm going to simplify this as much as I can before I input it back into my function that I'm building. So I'll factor out a pi. This becomes 16. And we also have to expand this part, which gets a little messy. To expand this part, you will have to rewrite it. It's a binomial. Y to the power of a third plus 2 times y to the power of a third plus 2. If you expand this, you should end up with the expression written below. And I'm going to substitute this expression into here. Now, since there's a negative outside of this binomial, each of these terms also become negative. So y to the power of 2 over 3 minus 4y to the power of a third minus 4. I finally produced my a of y function, which I can now substitute into this function, where I have v is equal to the integral between 0 and 8, and I'll combine 16 and minus 4, that gives us 12, minus y to the power of 2 over 3 minus 4y to the power of a third. And don't forget the pi, which we don't need to write in here, we can write it outside, dy. What you'll need to do next is integrate each of these terms. Since we already know how to integrate, I'll speed up the process by showing you what they are. The integral of 12 is 12y. The integral of y to the power of 2 over 3 is y to the power of 5 over 3, 3 over 5. And the integral of 4y to the power of 3 is 3 times y to the power of 4 over 3. Now, given that we've already done 3 other questions, 1 from this part and 2 from the other part, I'll let you figure the rest on your own. And so there you have it. That is how to find the volume of solids using integrals.